Autoscaling is a core component of increasing durability and availability on AWS. Autoscaling enables you to provision based on actual demand rather than on estimated demand. Autoscaling has health checking built in, and it can drop EC2 instances that are not responding and replace them with newly spun up healthy versions. All of this functionality works across multiple availability zones within a region, helping you achieve high availability with minimal manual intervention. Autoscaling should be used when you want to ensure that you have at least, say, one EC2 instance running at all times, or perhaps one or two EC2 instances in one or two of your availability zones always running. Another important use case is when you need to scale based on increased demand, or when you know of an up-and-coming event where your EC2 instances may be under a heavy workload. You can also ensure you scale back down to a normal EC2 presence and not waste money on idle resources. Autoscaling makes horizontal scaling easy based on demand or predetermined schedules. You can increase or decrease the number of EC2 instances running based on CloudWatch metrics. In the example on my screen, the autoscale policy will add an instance if the average CPU utilization equals or exceeds 70% for more than 300 seconds, which is 5 minutes. And the other part of the policy will remove instances from the autoscale group if the average CPU for the group equals or is less than 20% for 5 minutes. The launch configuration. Your group uses a launch configuration as a template for its EC2 instances. When you create a launch configuration, you can specify information such as the AMI ID, instance type, key pair, security groups, and block device mapping for your instances. An autoscaling group enables you to specify minimum, maximum, and desired number of EC2 instances in that group. A scaling plan tells autoscaling when and how to scale. You can base a scaling plan on the occurrence of specified conditions. Dynamic scaling, for example. Consider an autoscaling group that has two availability zones, a desired capacity of 2 instances, and scaling policies that increase and decrease the number of instances by 1 when certain thresholds are met. When the threshold for the scale out policy is met, the policy takes effect and autoscaling launches a new instance. The autoscaling group now has 3 instances. When the threshold of the scale-in policy is met, the policy takes effect and autoscaling terminates one of the instances. If the group does not have a specific termination policy assigned to it, autoscaling uses the default termination policy. Autoscaling selects the availability zone with 2 instances and terminates the instance launched from the oldest launch configuration. If the instances were launched from the same launch configuration, then autoscaling selects the instance that is closest to the next billing hour and terminates that. This helps you maximize the use of your EC2 instances while minimizing the number of hours you are billed for Amazon EC2 usage. If there is more than one unprotected instance closest to the next billing hour, autoscaling selects one of these instances at random. All right. So how about creating your own termination policy? You have the option of replacing the default policy with a customized one. When you customize the termination policy, autoscaling first assesses the availability zones for any imbalance. If an availability zone has more instances than other availability zones that are used by the group, then autoscaling applies your specified termination policy on the instances from the imbalanced availability zone. If the availability zones used by the group are balanced, then autoscaling applies the termination policy that you specified. Now, by default, instance protection is disabled. Instance protection does not protect autoscaling instances from manual termination through the Amazon EC2 console, the terminate instances command, or the terminate instances API. So autoscaling enables horizontal scaling, i.e. adding more instances rather than a vertical scaling, which traditionally tends to be increasing the size or capacity of an instance or machine. When an autoscaling rule is applied, the autoscaling configuration plan you define launches new instances based on that autoscale configuration. So autoscaling can be scheduled to scale up or down based on estimated usages, or you can set alarms to scale the size of an autoscale group based on CPU, network, or memory usage. So when any instance in your group reaches a certain threshold, an alarm will be created and the autoscaling group configuration will launch more instances to meet that demand. This is way more resilient. So if you have a question that mentions high availability, then most likely it is going to need a decoupled multi-tier architecture, and it is going to need to be able to scale parts of that application quickly to meet burst activity. So before we move into design mode, a few questions you need to ask yourself if you're presented with a scenario. Does it need to be highly available? Does it need to be scalable? Does it need to be fault tolerant? And in practical terms, does the system need to always be able to answer customer requests? And if so, then it needs to have a multi-tier architecture.